Hello there. So today this video is going to talk you through how to convert denary numbers to binary numbers. Now for year 7 and 8, one of your remote learning lessons is to do this. So I thought it'd be really useful just to talk you through some of the terminology and show you how to do this, because it's a little while since you've done it previously. You may well have forgotten. So what do we need to do first? Well, first off, we need to remember how computers work and how they're put together. Now I've got a picture here of a light switch. Okay, you might be thinking, why on earth have you got a picture of a light switch? Well, computers are actually made up of millions of tiny switches called transistors, which can simply be turned on or off. Okay, and that's what they look like. So these ones here, if I just bring the mouse over, okay, that's quite an old-fashioned transistor, and you'll notice it's quite large. The picture here is a zoomed-in picture of transistors. So you'll notice how transistors have changed from being quite large to quite small. But fundamentally, all we need to know is that inside here, we can imagine these as a switch that can be on or off. Now, the use of transistors is really important, because one of the main reasons computers got smaller is that transistors can get smaller. So if you look at this picture on the left hand side, this computer was quite powerful, but you needed a huge room to fit the computer in. Why? Well, because the transistors required were large. Okay, there were other reasons, but that's one of the main reasons. Whereas here, an iPhone, okay, is far more powerful than this computer ever was, but we're now able to make them really small. Why can we make them small? Because transistors are smaller. Now, what I also need to make sure is that you can talk like a computer scientist, because so far I've been using the words on and off. Okay, but a computer scientist doesn't use that terminology. We use two words. Okay, the first word, instead of off, we would use false, and instead of on, we would use the word true. Okay, so basically we see that computers or electricity can be in two states. It can either be false or true. Now with numbers, what we do is we don't use these words just because they're too long, and computer scientists like to keep things really simple. So instead what we do is we use the 0 or we use the number 1. Okay, but when we're dealing with binary numbers, the 0 represents false or off. Okay, the 1 represents the word true, or if you were talking to a non-specialist, the word on. Okay, so what computers are are a series of switches placed together. Okay, and what we can do is we can combine those switches together to get a computer to store some numbers. So again, obviously in a real computer, you wouldn't have a series of light switches, but it's quite a nice way to demonstrate how binary numbers work. Okay, now sometimes you'll hear the term bits. Okay, now we don't need to know this for today, but it's useful nonetheless. So each column is a bit. Okay, and here today and in your remote learning lessons, you'll have to I'll rephrase that. You'll have to use 5 bits. Okay, and what we can do is we can decide, okay, we want the 2 column on, and we want the 8 column on, but we want the other columns off. Okay, so let's have a look at the first example. So I need to write the number 9 in binary. Now, what I've got to do is, and it's similar to using a number line in mathematics, okay? What you've got to do is you've got to decide which of these numbers will fit in and make your target number. So let's take the number 9. So I've got 5 options. I've got 16, Now, we all know 16 is larger than 9, so we can't use that. So I turn that switch off. 8 does fit in number 9, so I can use that switch. Now that's started to make it a bit easier because I need to now get from 8 to my target number of 9. So I need to work out which number I need, and we all know that is 1. So I can simply go over here and say, okay, the binary number 9 looks like that. So I've got 1, 0, 0, 1, 0. Remembering that these numbers are representing the position of these switches. Okay, so we're saying on, off, off, on, off. Or as a computer scientist would say, true, false, false, true, false. Okay, now before we finish, let's just do one more. So this time, we want to write the number 19 in binary. So my first step is to find the largest number that will fit into my target. And in this case, 16 is my largest target. So next one, can I use 8? Well, a little bit of math. 16 plus 8 is 24. So if I used 8, I'd go beyond my target. So can't use that one. Same for 4. 16 plus 4 is 20. That's no good in this situation. However, 16 plus 2 takes me to 18. 18 plus 1 is 19. Okay, so when you come to do your binary lesson at home, the biggest recommendation I can give you is you need a scrap piece of paper. You draw out this table for every question you're given, and then all you need to do is repeat the process I've done. And if you do that, you will make really good progress with that lesson. Okay, thank you for listening.